Cloud architects are some of the highest paid roles in the entire tech industry right now. And with big tech spending over $700 billion on AI and cloud infrastructure this year, the demand for cloud architects is exploding. So naturally, everyone wants to know what it takes. But the problem is, there's still a lot of confusion about what this role actually entails and how it's different from being a cloud engineer or a solutions architect. I'm Suleiman. I've been in tech for more than 11 years. Today, I run my own businesses across cloud and AI consulting, my software company, StudyTech.ai, and my academy, where I've helped more than 900 IT pros, engineers, and career switchers master cloud engineering and land six-figure roles, including at companies like AWS and Microsoft. Now, in this video, I'm going to break down what a cloud architect actually does, how it compares to a cloud engineer and a solutions architect, the core skills that you need, and the realistic roadmap that you can follow today to help you get there. Let's start with the distinctions that confuses a lot of people. A cloud engineer builds. That is the job. You're writing Terraform code, you're deploying infrastructure, you're setting up CI/CD pipelines, and you're configuring services. You are very much hands-on. Sometimes it's in the console, but mainly in the terminal or in the IDE, building and maintaining cloud environments. Now, a cloud architect, on the other hand, focuses on design, right? That's the fundamental difference. The architect is not always deploying EC2 instances. The architect is the one who decided that EC2 was the right compute choice in the first place, and not Lambda, not Fargate, not ECS, right? They made that decision based on the project timeline, the cost, the constraints, the expected traffic. The architect designs the blueprint, whereas the engineer takes that blueprint and then goes and executes it. So the cloud architect is thinking, why are we building this? The cloud engineer is thinking, how do I build this? Now, a solutions architect is different again. A solutions architect is typically more customer-facing and pre-sales oriented, depending on the company that you work for. Now, if you've ever seen a solutions architect at AWS or Microsoft, their job is to work with clients, understand their business problems, and then map out cloud services to those problems. They're doing a lot of presentations and it's very much consultative, whereas a cloud architect is a lot deeper and more technical than that. They are designing the actual system architecture. It's more implementation focused, even though they're not the ones writing the Terraform, but they would have done previously in other roles, right? Because they have the skills to be able to dive in and do some engineering if needed. And now some companies blur these roles for sure, but in general, the engineer builds it, the architect designs it, and the solutions architect sells it. Now, I've worked in companies where I've had to work directly with a cloud architect, and I was a cloud engineer, so he would work with me, he would design a solution, and I'd go and implement it. Okay, so what makes up a great cloud architect? Looking back at the architects that I've worked with across my career, and also having worked as an architect myself, I've got a pretty good grasp of what you need, and I've boiled it down to 4 key pillars. Number 1, systems thinking. An architect doesn't think in services. They think in systems. And here is what I mean. A cloud engineer gets a ticket to deploy 4 services and connect them together. And that's what they do, right? They deploy it and job is done. A cloud architect gets a project brief, and before touching a single service, they're looking at the problem and mapping out the entire flow. Where does the traffic come from? How does the data flow? If this component goes down, what else breaks with it? They are essentially building the full picture in their head. Every dependency, every failure path, every scaling pressure point, and designing around all of that at once. That is the difference, right? Because the engineer sees the individual piece, the architect sees the entire end-to-end machine. Number 2 is trade-off analysis. As I always say, there is no right answer in architecture, only trade-offs. And this is a skill that separates a senior from a junior. You could design a system that's multi-region, fully redundant, automatic failover, incredible resilience, but it's going to cost 3 times as much and it's going to be significantly more complex to operate. So is that the right call? It depends. What's the budget? How big is a team maintaining it? Do they have the skill sets? What's the actual cost of the downtime for the business? A great architect doesn't pick the best option. They pick the right option given the constraints that they're working with. The skill is being able to explain exactly what they are gaining, what they are sacrificing, and why. Number 3, communication. This is the one cloud engineers underestimate the most. As an architect, you are the person in the room explaining the system to the people who didn't build it. You are presenting to stakeholders, project managers, CTOs, sometimes also completely non-technical people. And you need to make them understand why you've designed it in this way. What's it going to cost? what the risks are. So if you can't communicate the architecture clearly, it doesn't matter how good the design is. Nobody is going to sign off on it. And you have to adapt. Engineers want technical depth. Managers want outcomes and timelines. Executives want numbers and risks. Same architecture, but 3 different conversations. Number 4, breadth of knowledge. As a cloud engineer, you can get away with being a specialist in one specific area. Maybe you're amazing at DevOps and building pipelines. Maybe you are a Terraform wizard, right, and spinning up infrastructure as code. That is completely fine for engineering. But as an architect, you need to know a little bit of everything because you are not building a couple of pieces of the solution. You are designing the whole thing. The cloud engineers that you work with go deep on the individual components, right? They build it. Your job is to see how all of these pieces fit together and make sure the overall design actually works. And by the way, if you want my help to land a 6-figure cloud engineer role and start operating like an architect, which is one of my core pillars inside of my academy, then just click a link below and book a call with my team. We are getting tons of results right now, including Salim, who just got hired as a cloud security engineer at American Express, earning over $200,000 a year, and Rob, who landed 2 job offers after just 7 weeks inside of my academy. Link in the description below to book a call with my team. All right, so now you know what makes up a great cloud architect. And here is a practical roadmap that I'm going to give you. If you are an engineer looking to move into architecture, or if you are earlier in your career and you just want to know what to aim for, here is what you need to be building towards. By the way, before I give you that, something very important that you need to understand. You can't go from non-technical experience to becoming an architect. That's not reality. Whoever's telling you that you can go from zero to cloud architect is selling you a dream, because a lot of architects that I've worked with, practically all of it, all had engineering backgrounds. They've actually been the cloud engineer, for example. They've done the hands-on engineering and coding and then leveled up into a cloud architect, right? So you have to do the steps towards becoming a cloud architect. And naturally, the progression from a cloud engineer is in fact a cloud architect. All right, so the first thing that you have to learn is networking. If someone asks you right now to trace the full journey of a request from a user tapping a button on their phone all the way through to the response coming back, could you explain every single hop? The load balancer, the routing, the public and private boundaries, how the services talk to each other internally, right? That's the level that you need to be at. An architect who can't follow a request for a system end to end is going to design blind spots into every architecture that they design and every architecture that the engineers will build, right? Next up is compute. You need to understand why you choose one compute option over another. Not just how to deploy a container, but when a container is the wrong choice entirely. When is serverless the right call? I've seen over-engineered architectures where teams went full Kubernetes when EC2 with autoscaling would have done the job perfectly fine. More moving parts, complexity, and cost, but with no real business benefit. So you want to design for today's problems and not next year's anticipated complexity, which may never come. Data and databases. Now imagine that you're designing a system for an e-commerce platform. The product catalog needs to be read millions of times a day, but barely changes. That's one type of database decision. The order processing system needs to handle thousands of concurrent writes with strict consistency, because you can't have 2 customers buying the same last item that's in stock, right? And that will be a completely different decision. And then the company wants to add an AI-powered recommendation engine, which means that you now need to store and retrieve vector embeddings for similarity search. Again, 3 different data problems in the same project, 3 different architectural choices. An architect needs to understand why each one exists and when to use it. Because if you pick the wrong database for the wrong workload, you'll either overpay massively or you'll watch the system buckle under load. Security. Let's say that you're designing infrastructure for a healthcare company. Patient records, medical imaging, prescription data, all of it regulated, right? And all of it also target for hackers. Now, you can't just bolt security on at the end and hope for the best. From the very first architecture, you're deciding which services sit in the private subnets, how data is encrypted at rest and in transit, who can access what and under what specific conditions, how you detect something if something went wrong. Every single architecture decision has a security implication. The compute that you choose, the way the services communicate, how the logs are stored. And right now, with companies rushing to build AI into production, most of them are leaving security as an afterthought. Multi-cloud and hybrid cloud. Here's a scenario that you'll run into constantly. A bank has its core transaction processing running on-prem because of regulatory requirements. They literally cannot move it to the cloud yet, but their customer-facing mobile app runs on AWS. And the data analytics team just built their entire pipeline on Google Cloud because that's what the data engineers preferred. Now, all 3 environments need to talk to each other securely. Identity needs to work across all of them. Data needs to flow between them without creating any sort of compliance gaps. And someone needs to design how all of that fits together without it turning into a nightmare to operate. This is the kind of messy, real-world enterprise architecture that you will have to deal with. Then we have cost. Imagine a startup hires you to design their cloud infrastructure. They've raised a Series A. They've got 18 months of runway and they need to launch a product. So if you design an architecture that's going to cost them $40,000 a month when a $6,000 a month cloud architecture would have handled their traffic just fine, then you've just burnt through a huge chunk of their runway for no reason. On the flip side, if you go too cheap and the system can't handle the growth when customers start arriving, then you'll have a completely different problem. A great architect designs with cost as a first-class constraint, not something that you look at after the build. You need to understand how cost scales as usage scales, where the expensive decisions are hiding, and how to present that trade-off very clearly to your audience and your customers. AI infrastructure. This is something that you need to be aware of because it's where the industry is heading to fast. Companies everywhere right now are building AI into their products and internal tools, and all of that AI runs on cloud infrastructure. So as an architect, you're increasingly going to be asked questions like, where does this model get deployed? How do we keep inference costs under control? How do we make sure data stays private? Having a working understanding of things like RAG pipelines, vector databases, model serving, GPU compute, right, agents, even at a very high level, puts you ahead of the vast majority of architects out there right now. Now, I need to be very real with you here because you are not going to land a cloud architect role in just a few months, like I said earlier. Most cloud architects that I know have a minimum of 5 to 10 years of hands-on technical engineering experience. Worst case, they got 5 years. You can't design systems if you've never built systems yourself. But and this is very important, that shouldn't stop you from adopting an architecture mindset from day one, because that's what actually builds the foundation the right way. When you're learning cloud engineering and you're thinking about why you're choosing one service over another, what the trade-offs are, what happens if this component fails, you're already training yourself to think like an architect. And that does two clear things for you. It helps you get hired faster as an engineer because you're already demonstrating a level of thinking that most candidates are not having. And once you're in a role, you'll progress much quicker because you'll be already operating at a higher level than what's expected of you. Now, if you've got an engineering foundation and you're looking at cloud architect roles and you feel like there's never an ending list of expectations and skills, then this one is for you. The truth is, every company needs something slightly different depending on their projects and their technology stack. One role will be very heavy on security, another will be heavy on data, another one will be focused on AI infrastructure. And at this level, if you've got a specialty and you layer on cloud engineering, then really from there, you just need 4 key pillars: systems thinking, trade-offs, communication, and technical breadth. Now, in today's market, the job listings will vary. So the specific skills, typically, you can actually just pick up on the job and then just learn as you go. At the end of the day, people hire people. If you've shown competence throughout the interview process, then it doesn't really matter if you don't tick every single box. You just have to be able to build that relationship through the process and be able to demonstrate that you'll be able to learn quickly. Because every company just does things slightly differently. From their pipelines to their infrastructure to their monitoring to the way they deploy applications. You know, you've got the general engineering best practices, but the way people implement and companies implement, from startups to Fortune 500s to governments, is all slightly different. And that makes total sense because every company is completely different. They serve different customers. They work in different domains. They sell at different price points, right? They've got different levels of scale. Some companies process a lot of data, some companies don't. So you can understand why companies work slightly differently. So that architectural mindset approach is exactly what we focus on inside of my Cloud Engineering Academy. And it's why we are getting so many results right now. Rob went from technical support to hired as a cloud infrastructure engineer in just 7 weeks. And he even got a second offer with a base of $170,000. He came in, he acquired the skills with us, and became so good that he was able to build his own projects, which is the ultimate litmus test. Because at some point, you have to go out into the real world and solve real problems on your own. We're not here to handhold you forever. We are here to build you into an engineer who doesn't need us anymore. That's the goal. Mac went from IT help desk to systems engineer at AWS. Eddie went from a non-technical cybersecurity role to cloud security engineer with a $72K pay rise. Salim just got hired at American Express as a cloud security engineer, making multi-six figures. Silas switched careers at 42 and became a platform engineer. Dominic landed a cloud role at Siemens. Travel and Eric, Thomas Lab all landed cloud engineering roles in just the last month. Are those results guaranteed for you? Well, obviously not. It totally depends on your experience and your starting point. But what we do give you is the right system and the right roadmap and the right support combined with a mentorship to get you into a role. So if you're actually serious about landing in cloud or in 2026, then just book a call with my team. Links in the description below. As always, I'm rooting for you and become undeniable.